of this institution. Next, I would like to welcome principal, faculty, and students of Government College of Ropar. I welcome Head of PG Department of Physics, Mrs. Parminder Chima. She has always motivated us to touch new heights of success. Now, I also welcome Coordinator Dr. Neetu Chopra, Coordinator Dr. Surbhi Sharma, and all our dear teachers of organizing committee. Without their guidance and support, this event will not have been possible. I also welcome my dear team members of Institution of Innovation Council to this event. Last but not the least, I would like to welcome our dear audience to this event. And also I want to add, attendance link has shared in the chat box. So without any further delay, let's get started.
Frugal innovation is the process of reducing the complexity and cost of a good and its productivity. In this event, students will be explaining their experiments by displaying their videos and presentations. There will also be a question round in between. Now, I would like to call Madam Neetu Chopra to the frame.
Thanks, Ms. Vibhuti. On behalf of PG Department of Physics and KMB IIC, I, Dr. Neetu Chopra, Innovation Ambassador and Vice President, KMB IIC, take this opportunity to welcome all the participants of today's session, Journey that Leads to Frugal Innovations. My warm welcome to our Mentee Institute, that is Government College, Ropar. Our institute is providing innovative environment for the students to discover and develop their skills. If you look at the history, the innovation doesn't come just from giving people incentive. It comes from creating environment where their ideas can connect. So in this regard, today we have organized event Journey that Leads to Frugal Innovations, where we are going to share various innovative ideas developed by our students. My best wishes to all the presenters of today's event. Now I call upon Ms. Ankita, student of BSc Non-Medical STEM 6 for next proceedings.
Thank you so much, ma'am. So, what is the calculus of innovation? The calculus of innovation is really quite simple. Knowledge drives innovation. Innovation drives productivity. Productivity drives economic growth. So, innovation really is the core reason for modern existence. So, today in this event, we will learn some interesting physics concept through innovative projects of our KMVI. So, firstly, I would like to call upon Aditi Patania to present her presentation.
A very good afternoon to one and all present here. Firstly, we will discuss about Archimedes screw. An Archimedes screw is a simple machine that is used to lift water from when the screw is turned. It is used mainly for lifting water from a lower to higher level, such as rivers or lakes, to irrigate fields and also for draining water out of mines. Now, let's have a look on video demonstration.
Hello everyone, in this video I will give you a basic idea of Archimedes screw. For this demonstration we need PVC pipe, clear vinyl tubing, scissors, duct tape and some containers for water. Firstly, arrange the vinyl tube around the PVC tube in a spiral way as shown. Now, place the one end of vinyl tube in the container filled with water and start rotating the PVC pipe so that water from one end can raise to another container as shown. Now take another pipe of small diameter and rotate it like a screw. You can see water travels from one end to another, but this time it travels in lesser time. Now take another pipe of smaller diameter but increase number of spirals around it and repeat the procedure. This time you will see it takes same time as pipe 1. So time taken to travel from one end to another is inversely proportional to diameter of pipe and inversely proportional to number of spirals around the pipe. The basic principle behind this Archimedes screw states that any body completely or partially submerged in a fluid at rest is acted upon by an upward force. That's why water lifts from one end to another end. Thank you.
Thank you so much, Ankita, for this wonderful presentation. Scientific discoveries and innovation come from combining different existing technologies and different perspectives in a unique way. And I now invite Rushi for a presentation.
Greetings to all. I'm sure that every one of you have witnessed the band of colors in the sky, that is rainbow. Rainbow is formed when white light from the sun is scattered by water droplets through a process called refraction. This causes the white light to split into different colors. Longer wavelengths appear as red and shorter wavelengths appear as blue or violet. What happens is when you shine the white light into the water, the light bends. But white light isn't just one color. Instead, it's a combination of different colors. Each color bends at a different angle because each color travels at a different speed. When you reflect the light back out of water using the mirror, you are reflecting the white light that has been broken up into the full rainbow of colors and a rainbow appears. Now, let's have a look on a video demonstration.
To all of you, myself Kajal Khanna and I am a student of Kanya Mahavidyalaya Jalandhar. I am pursuing a Bachelor of Science. Today I will show you how is rainbow formed. So let's get started. The material that I have used for this experiment is white sheet, bowl, mirror, water, tape and scissor. A bowl and add some water. But keep this thing to be right, the bowl half should be filled. Put the mirror in the water. But the mirror should be in the half water and half outside. Paste the mirror into the bowl with the tape so that they don't fall in the water. Then place the white sheet in front of mirror in some distance. Before falling a light in, first of all switch off the light of room. Take a torch, then fall a light on the mirror so that light is reflected and appear on white sheet paper, which will show you rainbow split. The principle of this experiment is lights enter a water droplet, slowing down and bending at its source from air to denser water. The light inside the droplets, which makes the two components, wavelengths and colors. When the light exists droplets, it makes a rainbow.
Thank you so much, Rushi, for this wonderful presentation. Now, let's moving to another presentation. Now, I would like to invite Ms. Poonamjeet Kaur.
Good afternoon to all. I Poonamjeet Kaur. I am here to present presentation on the topic Bernoulli's principle. Bernoulli's principles state that an increase in the speed of fluid occurs simultaneously with the decrease in static pressure or decrease in fluid potential energy. The simplified form of Bernoulli's equation can be summarized in the following memorable word equation. Static pressure plus dynamic pressure is equal to the total pressure. Every point in the flowing liquid, regardless of the fluid speed, at that point has its own unique static pressure and dynamic pressure. Let's see the video related to that.
Hello everybody, today we are going to demonstrate Bernoulli's principle. For this, you need two balloons and a thread. Let's get started with the balloon experiment. Fill the balloons with air and attach them to the string or the thread that is tied at both the ends. Now, if we blow air in between the two balloons, let's see what happens. Unlike we expected, the balloons come together and get stuck when air is blown in between them. Why does it happen? When air is blown between the balloons, the air starts moving at a higher speed than the air around it. Daniel Bernoulli has explained that fast-moving air exerts lower pressure on any object than the static air. Air is flown between the balloons. Air on the farther sides is static. Hence, pressure between the balloons is lower than the pressure on the farther sides of the balloons. This pushes the balloons inside, making them stick to each other. Now, let's do something interesting. Let's perform straw mister experiment, or we can say creating a fine mist water spray using two straws. For this, you need two straws, colored water, and white sheet. Put the straw inside the colored water and hold the other straw horizontally and parallel to the straw inside the water. Blow as hard as you can. Now the water from the glass rises above the straw and is sprayed out, as you can see. As the air above the straw dipped in the colored water is blown, it moves at a faster speed and the pressure drops. The low pressure at the opening sucks at the water below and it is sprayed out. This was another wonderful demonstration of Bernoulli's principle.
Thank you so much, Poonamjeet. Now it's time for some question answers. Be ready.
The first question is, aircraft flies on which principle? Students can give their answers in the chat box. The question is, the aircraft flies on which principle? Hurry up, students, let's make this event more interactive. Yes, it's right, Poonamjeet Kaur. The correct answer is Bernoulli's principle. The next question we have is, Bernoulli's principle is based on law of conservation of first option, mass, second, energy, third, momentum, fourth, none of the above. I repeat the question, Bernoulli's principle is based on law of conservation of mass, energy, momentum, or none of the above. Yes, Tanvi, Ananya, right answer. The correct answer is conservation of energy. Yes, Shanu Thakur, correct answer. Now, I hand over the virtual mic to Lovely. Thank you everyone for answering.
I really enjoyed this session. Hope you all do. Burton Richter once said, innovation and renewal are required to keep a laboratory on frontiers of science. I now invite Rushi for a presentation.
The next concept we have is air pressure. We are surrounded by air from all the directions, and this envelope of air around us is what we call atmosphere. Air is being pulled by the Earth's gravitational force. This force applies pressure on the air in the downward direction. This pressure exerted by air is called air pressure or atmospheric pressure. Air pressure acts in all directions. Here is in one example you can perform at home. Take a plastic bottle and fill it with water and a surfboard. Place it to an open end of bottle. Hold this paper so that it does not move and invert the bottle. Now let go of the cardboard. What did you see? The cardboard sticks to the surface. Why does it happen? It is held to the surface because of the air pressure that is pushing the cardboard in the upward direction, and it is sufficient to counter the downward push exerted by water. Now let's see the video demonstration on air pressure.
I am Harmanpreet Kaur from BSc Non-Medical. Air takes some space and has weight. Air pushing us down all the time. We can't feel. But air and the pressure of air can do pretty powerful things. Here in this video, I will show you a demonstration how air pressure is powerful. What you will need is balloon, plastic bottle, bendable straw and a sharp thing. Make a hole near the mouth of plastic bottle. Insert the straw in the bottle. Fill the bottle with the water. Now blow a balloon and hold the neck with fingertips. Carefully fix the balloon on the mouth of the bottle. When you release the air from balloon, it creates pressure on the bottle and thus pushes the water out and creating a water fountain. Now replace the water by oil and follow the same procedure as we done in the case of water. Now let's observe what will happen. Let's look what actually happened in the experiment. The air inside the balloon is under higher pressure. When you place the inflated balloon on the mouth of the bottle, the air pressure on the top of bottle increases. This pushes down the water in the bottle, which rises to the straw and comes out. We observe that oil comes out very slowly as compared to water. The reason behind is that oil is denser than water. Thank you. I hope you learned something new.
Thank you so much, Rushi. Now it's time for another presentation. Now I would like to invite Ms. Hara Amanpreet Kaur for her presentation.
My warm wishings to everyone. Today we have organized this event in which we are going to learn the concepts of physics. I assure that this will take you in the physics world. So starting with the first topic, so you are seeing this picture. So can you answer that this is automatic street light or not? You can answer in the chat box. This is automatic street light or not? Yes, it is not. It is a picture of lamp used in the old times for lighting. But now we are seeing automatic street lights on the road. So automatic street light reduce the wastage of power. LDR, that is light detecting resistor, is very useful in light dark sensor circuit. Normally, the resistance of an LDR is very high, something as high as 10 lakh ohms. So now going to the working of it. So light falls on the LDR. So light is coming from the sun and fall on the LDR. It shows that its minimum resistance voltage drop across the LDR. That is less than the voltage of transistor. So no current will go from the collector to the emitter and transistor remains off. So when light falls on the LDR, it stops. And when light is not present, then it on. Like the automatic switches on the lights when the sunlight goes below the visible region of our eyes. So around 77 to 81% of power consumption can be reduced by using this system. So now let's see the demonstration video performed by the Ankita Thakur, student of BSc Non-Medical.
for an amazing presentation. Before going further into the event, let's have another round of quiz. Over to you, Vibhuti Di.
The next question we have is, atmospheric pressure is measured by an instrument called, I repeat, atmospheric pressure is measured by an instrument called, everyone to give their answers in the chat box. Yes, Loveleen, right. So the correct answer is barometer. The next question we have is, what is the full form of LDR sensor? I repeat, what is the full form of LDR sensor? Audience, please try to answer it. Yes, the correct answer is light dependent resistor. Next, we will be having the last video of this event. So I invite Loveleen to continue.
Innovation is a change that unlocks new values. I now invite Sandeep for a presentation.
Thank you, Loveleen. Good afternoon, everyone. Now let's learn the concept of no magnet motor. Rather than magnets, the rotor here uses wound coils, which called no magnet motor. The new Mahle design uses no magnets, instead using powered coils in its rotor. This new kind of magnetic free motor that does not require any rare earth metal. Unlike previous, it transfers power to spinning rotor using contactless induction. So there are basically no free surfaces. The new magnetic free motor is highly efficient at almost all its operating points. The new electric motor is also characterized by high degree of durability because the necessary transmission of electric current between the rotating and stationary parts inside the motor take place without any contact. So there is wear free. So now let's have a look on the demonstration given by Kajal, student of BSc Non-Medical Semester 6.
Hello everyone, my name is Anita Sharma. I am a student of BSc Non-Medical Chemistry. My experiment is how to make a no-magnet motor. Material required: cutter, safety pins, 1.5 volt battery, rubber band and copper wire. In this experiment, you need an insulated copper wire and a battery. Take a meter long 25 volt insulated copper wire and bind round and round on a new 1.5 volt battery. Now remove the coil, which is looking like a spring, and then tie knots at the two ends and pull them up so that the coil becomes like a circle with two ends. Now this wire is insulated, so you scrap insulation completely from one end. You see shining copper. On the other side, you scrap on the three sides of copper. Now take a 1 cm wide rubber band. Now take two long safety pins and snap them to the plus-minus terminal of the battery. You just need to coil a gentle nudge and coil will keep shining. Place the magnet to speed motor and reverse the magnet to slow the motor.
It was a wonderful presentation, Sandeep. Without change, there is nation, no creativity or no incentive of improvement. Those who initiate change will have a better opportunity to manage the change that is inevitable. With this, I invite Ms. Prajinder Kaur for next presentation.
A very good afternoon to one and all present here. Now, let's learn about surface tension. It is how to demonstrate surface tension of water using black pepper. Now, the question arises, what is a surface tension? Surface tension is the tendency of fluid surfaces to shrink into the minimum surface area possible. Here are some of the examples: a drop of liquid, soaps, and detergents. Now, the question arises, why does black pepper move away from the soap? Well, pepper is a hydrophobic, meaning that water is not attracted to it. As the soap moves into the water and the surface tension changes, the pepper no longer floats on the top, but the water molecules still want to keep the surface tension going. So they pull back away from the soap and carry the pepper along with them. Let's have a look on the video presentation.
As we have a glass filled with water, we have to shift this water to the bowl. What we are observing is, while shifting water to the plate, water seems to be fall with the surface of glass. Like when we are shifting this water, water seems to be out of the bowl. This is due to the action of the adhesive force, and at the boundary of glass there are few molecules of the solid and liquid. Means their adhesive force is acting. Adhesive force. Let me explain you what is adhesive force. Adhesive force is a force between the different molecules. After this, we have to add some amount of black pepper to it. As we observe, when we add black pepper, we observe that the water holds the molecules at the surface itself. We have to take Dettol on the earbud, as I have taken. Now, dip this earbud into the water. As we are observing, when we dip earbud into the water, we have observed that the molecules of black pepper are settled down or are shifted. Coal is used because it's a soap solution and decreases the surface tension of the molecules.
Thank you so much, Barjinder. Now it's an end to all the presentation. It has been a wonderful event and a great experience for both the participants and the listeners. Thank you everyone for joining us today. It is to inform you all that feedback link of this event has been shared in the chat box, so please do fill it. Now, I would like to invite Dr. Surbhi Sharma for the vote of thanks.
So, good afternoon, everyone. On the behalf of PG Department of Physics and KMB IIC, I, Dr. Surbhi, Innovation Ambassador, would like to take this opportunity to thank the principals, staff members, and students of Government College of Roper for joining us. Hope all of the participants have learned a lot by understanding concepts of sciences, and I'm sure that such learning will definitely lead them to explore innovations. I hope our collaboration will bring desired results also. Looking forward to have the participation from Government College Roper in our upcoming events also. Here, I would like to express my gratitude to Mrs. Parminder Kaur, Head PG Department of Physics, Dr. Rashmi Sharma, President KMV IIC, for their consistent support and guidance. I feel proud to appreciate the efforts of our organizing student committee, without whose overwhelming support and enthusiastic presentation, it would not be possible for us to organize such a successful event. So we are proud of our budding innovators at KMV. So at the end, thank you very much for joining us. And let us we have a good group photo. So please turn on your cameras, everyone. So let us we have a group photo and with a cheering smile on our faces.
Please for a few seconds keep your videos on, because we wish to have a good collage of your pics. It's a request from our side. Please keep your videos on for a fraction of seconds. We wish to see your lovely faces. Once again, thanks to all. And a very special thanks to Government College Roper for joining this event. And a big round of applause for our presenters of today's show.
Ma'am, ਅਸੀਂ ਗਵਰਨਮੈਂਟ ਕਾਲਜ ਰੋਪੜ ਵੱਲੋਂ ਤੁਹਾਡਾ ਬਹੁਤ ਥੈਂਕਸ ਅਸੀਂ ਕਰਦੇ ਹਾਂ ਕਿ ਸਾਡੇ ਬੱਚਿਆਂ ਨੇ ਬਹੁਤ ਇਨੋਵੇਟਿਵ ਆਈਡੀਆਜ਼ ਆ ਜਿਹੜੇ ਤੁਹਾਡੇ ਕੋਲੋਂ ਲਏ ਆ, ਕਿਉਂਕਿ ਸਾਡੇ ਬੱਚਿਆਂ ਨੂੰ ਇਸ ਤਰ੍ਹਾਂ ਦਾ ਮੌਕਾ ਪਹਿਲੀ ਵਾਰ ਮਿਲਿਆ, ਮੈਨੂੰ ਲੱਗਦਾ ਕਿ ਉਹ ਇਸ ਤਰ੍ਹਾਂ ਜੁਆਇਨ ਕਰੇ ਨੇ ਬਹੁਤ ਚੀਜ਼ਾਂ ਉਹਨਾਂ ਨੂੰ, ਰੇਨਬੋ ਕਲਰ, ਬਰਨੌਲੀਜ਼ ਪ੍ਰਿੰਸੀਪਲ ਤੇ 에ਅਰ ਪ੍ਰੈਸ਼ਰ, ਆਟੋਮੈਟਿਕ ਸਟਰੀਟ ਲਾਈਟ। ਮੈਂ ਵੈਸੇ ਆਰਟਸ ਦੀ ਸਟੂਡੈਂਟ ਆ, ਪਰ ਮੈਨੂੰ ਬਹੁਤ ਅੱਛਾ ਲੱਗਿਆ ਕਿ ਬੱਚਿਆਂ ਨੇ ਬਹੁਤ ਹੀ ਅੱਛੀਆਂ ਪ੍ਰੈਜੈਂਟੇਸ਼ਨਸ ਕਰੀਆਂ ਤੇ ਸਾਡੇ ਬੱਚੇ, ਮੈਂ ਹੋਪ ਕਰਦੀ ਹਾਂ ਕਿ ਇਸ ਨੂੰ ਫੋਲੋ ਕਰਕੇ ਉਹ ਵੀ ਅੱਗੇ ਨੂੰ ਇਸ ਤਰ੍ਹਾਂ ਹੀ ਕਰਨਗੇ। ਥੈਂਕਸ ਗਵਰਨਮੈਂਟ ਕਾਲਜ ਰੋਪੜ ਵੱਲੋਂ ਕਿ ਤੁਸੀਂ ਸਾਨੂੰ ਇੰਨਾ ਵਧੀਆ ਮੌਕਾ ਜਿਹੜਾ ਪ੍ਰਦਾਨ ਕੀਤਾ। ਮੈਡਮ ਥੈਂਕਸ।
Thank you, ma'am. And hope in the coming days we will share some more events and we'll do the innovations together. So now we are in collaborations. We will definitely do.
Welcome.
And we'll update you about our upcoming events too.
Okay, ma'am. Okay.
Thank you. Thanks to all. Okay.